Okay, so we'll start now. Welcome everyone to the first weekly session, the live session for the course Earth Sciences for Civil Engineering Part 1 and 2, which is being taught by Professor Javedan Malik from the Department of Earth Sciences, IIT Kanpur. And these live sessions will be taken by me, Ananya Mukherjee. I am also from the Department of Earth Sciences, IIT Kanpur. So the whole idea of these live sessions would be that these will be sort of a doubt clearing and problem solving sessions which will be related to the weekly material that you will be getting as the lecture material and also the assignments. So mostly this will be based concentrated on the assignments that you all will be getting every week. So this will be held 1 hour every Tuesday from 6 to 7 p.m. For the next 8 weeks. And since the assignments are mostly based more on the conceptual understanding of the entire subject and the course, so I will be summarizing the lecture contents that are given pertaining to the assignment questions that you all have, and obviously the solutions won't be given at like the exact solutions won't be given, but hopefully through the doubt clearing talk that we have and also the material that will be shared with you from the session, you all will be able to come up with the solutions for the assignments. So now we will start with the presentation. So as you know that the course is most designed to introduce you towards the understanding of the earth sciences and the earth processes, the interior of the earth and the constituents of the earth that is going to help you in the subject of civil engineering. Also the materials that you use, the site identification analysis, and later on you will be introduced to different types of geological hazards, fault systems, the features related to faults and how they impact different kind of civil engineering projects, construction projects, and also try to understand the importance of these geological structures in the building of dams and tunnels. So, and also later on we will learn how river geomorphology and groundwater is monitored and how they also impact the analysis for civil engineering, and mapping, monitoring and management of different hazards like tsunami, landslide and floods. So to understand these, first we will try to understand geology. Now geology is the branch of science that deals with the study of the earth's surface, its origin, composition, the structure and also different features and landforms that are found on the surface of the earth, how they are formed and what kind of processes are forming them. So we try to understand these by applying concepts of physics, chemistry, and also life sciences. Since we also try to understand the life on Earth, present and also in the past. So that is why. So as I mentioned before, the subject of geology and also the Earth systems has importance in understanding for your civil engineering constructions projects, and also how certain regions that are susceptible to failures due to faults or different kind of hazards is going to be affecting your the property over there. So later on, we'll see the aspects of geology that you will be dealing with is mostly geomorphology. That is the study that is done to understand the landforms that are formed on the Earth's surface due to glacier action, river action, wind action. So these erode, weather, and also deposit different constituents or components of the Earth to kind of form different landforms and features. And as you can see over here, that we can see the sorry, my pointer is gone. So these are the landforms that are made by the action of the wind. So yeah. So sorry. Okay. So the next that we will be dealing with in mineralogy, that is the study of minerals, and minerals mostly form the rocks, so which will be studied in petrology. So understanding how rocks are formed is also going to help us in understanding the materials that are used for different kinds of projects, and the minerals is also important for that reason. And then later on we'll study structural geology. So the structural geology is going to let us understand how folds are formed, faults, and also joint structures. These play a very important role in understanding the regions where you are going to choose for your sites, because these will either create failures, or they won't. So because of that, we need to understand these geological structures also. So to understand everything, so we will first start with the origin of the solar system. So as we know that you all must be knowing about the Big Bang theory, and except for other than that, there are different other origin theories also. But some of them have said that there are different kinds of there was a large hot gaseous nebula which cooled and contracted and formed the sun, and then due to sun's own gravitational attraction, the different kinds of components later on consolidated and formed the different planets that we see. And there are a few other theories over here. The recent theory that is there is it said that disc-shaped cloud of gas and dust were there around the sun, and later on they gradually aggregated in different planets. So as we see that since uh, the inner planets are mostly denser in state, and they are closer to the sun, and the gaseous ones, which are also called the Jovian planets, are lighter and they are far away from the sun. So over here, as you can see, the comparison can be given according to the composition and the densities and also the sizes. So then later on we see that the Earth's age that we till now know is around 4.5 billion years, plus minus 50 million years, and the such ages are usually determined through different kinds of dating procedures. So we have obviously radiocarbon dating, there is potassium and argon dating, then there is rubidium, strontium, and uranium, lead. So these are the different dating methods that are used, and the dating for dating we use different kind of minerals and the different kind of elemental crystals that are found in the minerals. So over here we can see that the oldest dating record till now that we have is from a zircon crystal from Western Australia, and it has given us the age of 4.3 billion years old. So, but these are just dating. So we know how old the earth is, but now we need to understand how the different kind of landforms are created across the globe, across the earth's surface. So one of the principles that we use is called principle of uniformitarianism. Now the idea of this principle is that whatever processes are happening right now in the present day has also happened in the past. The rate of the processes happening now and in the past could be different, obviously, but the way, the manner in which they happen remains the same, uniform across the universe. Now, for example, I have taken here is the Grand Canyon. We can see the rivers flowing through the canyons. Now, we study how the river is kind of forming the landform here right now to understand how it might have formed the canyons in the past. So, this is how we use the principle of uniformitarianism, and it was given by a scientist named James Hutton. So now, as Earth has formed, as we all know, Earth is very unique in its compositions around itself and also within itself. So we have four kind of different spheres that interact together to sustain life on Earth. So we have the hydrosphere, that is the water cycle and the water components. Then we have the atmosphere, and as we all know, the different layers on this. And we have the geosphere that is pertaining to the rock cycle that we have, the formation, destruction and deposition, and again reformation of some of the rocks. And then we have the biosphere, where the life on the earth interact with all three of these spheres, and that is called biosphere. So now we know the earth has formed, but the earth, when it had formed, it was just different kind of components aggregated together, material aggregated together. Now this material slowly consolidated, and the cooling started. Now the cooling started, and with the cooling, different kind of layers have formed. Now these layers are due to the different densities that these layers have. Now we know that the crust is on top. Now the crust is made up of two components, the continental crust and the oceanic crust. The continental crust is lighter than the oceanic crust. So that is why the oceanic crust is quite thin and the continental crust is thicker than that. And then we have the mantle. So the mantle, the uppermost part of the mantle and the crust together is known as lithosphere, and the upper part, the partially melted part of the mantle, is called the asthenosphere. Now mantle on its own is said to be semi-solid in its state, and then you have the core. Now the core has the most density because it is mostly made up of iron and nickel. So the outer core is liquid and the inner core is solid. Now obviously, since we cannot really penetrate so deep into the earth, how do we know these informations? How do we know these states of the different layers that we are seeing over here, that we are discussing over here? So for that reason, we use something called seismic waves. Now seismic waves are naturally created by the earthquakes that happen across the earth, and these earthquakes generate P and S waves. As you can see over here, these travel through the earth's interior, and then they are recorded on the other they are recorded across the globe at different seismic stations. So from there we get an idea about the kind of the states of the matter that are there inside the earth. Now we know that S waves cannot travel through the liquid medium. So over here, as we can see, this is called the preliminary earth reference model, PREM model. So over here we see that the plot to the left hand side is the S wave plot, and the plot to the right hand side is the P wave plot. we see that between around 2900 kilometers to around 5100 kilometers, there is no S wave. So when these recordings were made and there was a portion on the earth surface where S waves could not be recorded from a certain earthquake that they are trying to study, we see when the S waves are not recorded, we assume, we have interpreted that there is a liquid present over there. So this area where the S waves are not visible over here, then there is no information. That is due to the outer core being liquid in state, and also the area where S waves are not recorded is called the S wave shadow zone. So and then we see the P waves also traveling, but P waves travel through the outer core. Now you can see that this is the graph of depth with velocity. We see that there is a certain sudden drop in the velocity. Even over here we can see there are sudden drop in velocities. Now these velocity drops are caused by the different compositions that are existing between the layers. So due to these drops, these areas where the drops occur, these are actually denoted by different discontinuities. We have the Moho discontinuity, which is the discontinuity between the crust and the mantle. We have the Gutenberg discontinuity, that is a discontinuity between the mantle and the core. So as we can see over here, there is a drastic drop in the velocity. So and there are some other discontinuities that are not mentioned here, but between the upper crust and the lower crust there is a Conrad discontinuity, and between the outer core and the inner core we have the Lehman discontinuity. So now we see, we understood the interior of the earth is made up of different layers with different compositions and different densities. But how do we know that different kinds of the landforms that are formed? We try to understand that there is a principle of isostasy, which actually deals with it deals with the balance of the gravitational balance that exists between the elevated areas and the depressions that are there. So that exists because of the different heights of the crustal blocks and the densities of the crustal blocks. Now there are two kinds of hypothesis that is present. So there is one Airy model and there is Pratt model. Now Airy model says that the crustal blocks float at different depths. Now these depths are called compensation depths. So if suppose I decrease the height of this block, okay, so the block will rise up. That is what it means to have a isostatic compensation, okay. And Pratt's model suggests that all of them have all the blocks have the same compensation depths but different heights, okay, different heights and with different densities also. Now the example can be very easily understood when a mountain is building. Now the mountains, as later on I'll tell you that it happens because of the collision of two suppose plates, okay. So they are colliding and the mountain is rising. Now as the mountain rises, the amount of mass is increasing, but as I had told before, continental crust is lighter than the oceanic crust or the crust right below the continental crust. So since it is lighter, it has to stay on top. But how would it compensate for the added on mass? The root that is same, the bottom part of the mountain would go deeper, okay. So it would go deeper, and the similar way when mountain erodes, okay, the weight is taken off, the mantle below the crust over there near the mountains, it will bounce back. Now this bounce back thing is very easily seen where we see ice caps, okay. Now the ice sheets are melting, like the ice sheets which were very thick before, so they were melting and when the weight was decreasing, the mantle, the crust was uplifted over there. Now the crustal thickness seems to be decreasing over there. Okay, so this is the whole idea of isostasy, and why this will be important will be coming in the next slides. So we know that the earth is made up of different continents, okay, and we have heard before that these continents were actually situated all together at one point of time in earth's history. Okay, it was called Pangea, and the big and the larger ocean body or the water body that was present was called Panthalassa. Okay, later on, due to some processes, the continents started breaking apart. Now, during the entire Earth's history, a lot of times these continents have broken apart and they have assembled together. Okay, so how did these processes happen? One of the theories that has been put forth is called mantle convection currents. Okay, so the crust is floating on top of the mantle or the asthenosphere for that matter. The lithosphere is floating on the asthenosphere. Now, because the mantle is pretty heated up, okay, so we formed several convection currents. Now the convection currents actually drive the plates that are floating on top to either move towards each other or away from each other. So this was one of the theories that came later on to try to understand how the continents are moving with respect to each other. So that gave to the theory of continental drift theory. So the continental drift theory has been given by Alfred Wegener, and the whole mantle convection current and some other the plate tectonics have been derived from this continental drift theory. Now, continental drift theory was based on different assumptions and also observations. Few of the observations have been the similar shape of the coastlines and also the fossils, that is, records of past life. So these have been the evidences on which the plate theory is the continental drift theory is based on. So then we see that these plates, okay, because of the whole mantle convection currents, these are moving towards each other, away from each other, or they move past each other. Okay, now these different kind of plate movements give rise to different plate boundaries. Now plate boundaries are three types. There is a divergent boundary where due to extensional processes, the plates are moving away from each other. Now the plates are moving away from each other. Now the lithospheric plates that we are talking about, it consists of both continental and the oceanic crust. Okay, so when the continents or the plates are moving away from each other, the deeper crust is also moving apart. When it's moving apart due to the mantle convection current, the fluid and the hot magma rises on top where the extension is happening. Okay, now this gives rise to new material coming from the new magma and forming a ridge over there. Now these ridges have been called mid-oceanic ridges. Okay, so the mid-oceanic ridges is one of the features that is formed when you have a divergent plate boundaries. The plates are moving away from each other. Now the next type of plate boundary is called the convergent plate boundary. Now the convergent plate boundary says that the plates are moving towards each other. Now when the plates are moving towards each other, either you have oceanic and oceanic plates or crust coming together, you have continental and ocean crust coming together, and also you have continent and continental crust coming together. So when continental and continental crust are coming together, we have collision zones, and they form mountains. One of the very highly named examples is obviously Himalayas. So they have been formed due to the collision between the Eurasia plate and the Tibetan Eurasia plate and the Indian plate. Okay, so that is how mountains form. Now, also when the oceanic and the continental crusts are, colliding with each other, converging towards each other, the denser plate, that is the oceanic crust, goes below the continental crust. Now, when it is going towards the going under it, the melted, the material that is melting because it's reaching lower in the depth, and due to the heat in the atmosphere, not sorry, not atmosphere, the asthenosphere, because of the heat, the material that is melting over here, it rises again at some of the extensional areas that is happening because of the diverging plate boundaries. So this is the entire circle. Now, where some places where the subduction is taking place, you have very deep trenches forming. One of the deepest trenches that most of you might be knowing is the Mariana Trench. So this is also one of the features that is formed due to the convergent plate boundary. Now the next type of plate boundary that we have is called the transform plate boundary. So where the plates are moving against each other. Now when it's moving against each other, these areas are constantly experiencing earthquakes over there. Okay, because they are moving against each other, it's releasing the stress that is held between the plates and at the plate margins. Okay, so these are the different boundaries that happen, and the processes which is driving these plate boundaries to either converge, diverge, or move past against each other is due to the mantle convection currents that I had uh, uh, you know talked about before. So because of these processes, there are different models that have been suggested. So the plate models is what I just explained to you, where you have ridge formation, where the plate boundaries where the plates are moving away from each other, and where they are colliding with each other. You have mountains over here, since you can see hopefully that this is a ridge formation, this is the extension. So again the magma is coming on top over here. Okay, so and this is also where some places where you have big mantle plumes coming and driving the plate boundaries to move away from each other. And over here in this map we can see that these are the kind of different plates that are there. There are major plates and then there are minor plates, and the red marks are essentially the boundaries between these plates. The ones that you can see in the triangles are where subduction is happening. Okay, over here since you can see over here the Indian plate is kind of hidden over here, but you can see that this is one of the collisional places. Okay, in the where plates collide, it's called subduction zone, because most of the time one of the plates is subducting below the other. Okay, the collision ones is different where the mountains are formed, but trenches are usually formed where you have these subduction zones. And over here you can see there are different kinds of straight lines over here. These are called faults, extension faults. Okay, so these are extension faults, and then you have transform faults also. One of the transform faults is over here. Okay, so these are the different features that are formed due to these plate movements and the plate margins. So this is still where week 1 has been taught as per the material that has been given, and hopefully the summary of the lectures and also kind of some of the information that I have given here is going to help you in solve the assignments that you have. Here are some of the takeaway questions. Obviously this the PPT is going to be given later on, but yeah, so these are some of the questions that you can find out the answers to. Try to understand some of the like over here I have asked like which rocks are used for these. You see what rocks these are, what kind of rocks these are, and maybe also find out where in India they are found, and also the kind of different kind of landforms that are suggested over here. You can find these out and try to gain more understanding towards the processes, and also try to increase the interest for the subject itself and geology. And now I will be taking questions. So if anybody has any question, you can either type it out in the chat box, or you can unmute yourself, and then you can ask me then also. And yeah, there is a question, the recorded class of the meet and PPT. See, it will be available later, but the whole point of this live session is to, to increase the interaction between youth, the the ones who are enrolled, and the kind of us, that we are taking these sessions. So any doubt you have in the lecture content, or the weekly assignment that you're getting, so you can just ask them over here. It is an open interaction session. The recordings and everything will be there, but it will be given later on. So I would highly motivate you to use this to interact with us, with me, for now. So any questions regarding any of the things that has been shown over here, any of the assignment questions, or any of the weekly review questions that is given after every lecture? Please go ahead. Is it so that everybody has understood everything? See, this is an introductory class, but I would suggest that you interact. Is there something that you would want to know about things that is discussed? So please go ahead. Okay, anybody has any suggestion regarding these sessions? Is there something else that you would want me to kind of explain or do with these sessions? If any, then please you can suggest that also. Yeah, is everybody of like UG level here, or is there any PG student over here also? Let's just type it out in the chat box if you can. Okay, I got someone saying UG. Okay, ma'am, will you explain again the discontinuities? Okay, thank you. So the discontinuities. Okay, so over here we have seen that there are different layers that is making up the interior of the earth. Okay, uh, the crust is made up of two layers. One is continental and one is oceanic. Now the continental crust is usually made up of minerals that contain silicates and aluminium silicates. Okay, and then you have the oceanic crust that has more of sea silicates and mafic minerals. Mafic minerals as in iron, magnesium, manganese. These are some of the denser and mafic materials. Okay, can everybody see my screen? Just somebody just type in the chat box once. Is my screen visible?
Visible only.
Okay, visible only. Okay, because over here I cannot see my screen suddenly. Okay, so as I was explaining, So you have different crust. One is the lighter cealic crust that we say, and the denser oceanic mafic crust. So the discontinuities that I was saying, that usually lies where you have these compositional differences. Okay, see, the crustal is most of the silicate material. Now the mantle is mostly made up of peridotitic material. Now the peridotites are mostly denser than the crustal elements. So again you have a compositional difference, and this compositional difference is then marked by a discontinuity. This discontinuity has been suggested by different kind of studies, as I had mentioned, these P and S waves. We see that the velocity of the S wave rises, or maybe P wave rises or decreases. Okay, these are the signatures that there is a compositional discontinuity, and these compositional discontinuities are then marked. So between upper crust and lower crust you have the Conrad discontinuity. Then over here Moho is marked. Now this Moho is the Mohorovic discontinuity that is marking the compositional difference between the crust and the mantle. Okay, crust and the mantle. And then you have the Gutenberg discontinuity, that is marking the discontinuity between the mantle and the core. Okay, and then later on you have one more discontinuity that is marking the compositional or the I said that the outer core is liquid and the inner core is solid. So there is a region of region that is marked by the Lehman discontinuity. Okay, so these are the discontinuities. Any other query you have regarding the discontinuities? I'm not sure who asked the question. There was no name as such. Ashwini. Okay, Ashwini, is it clear now? Discontinuities? Just type in the chat. It's okay. Okay, thank you. Okay, does this lecture will be available after timings? Okay, there's no issue. This lecture is being recorded, and then later on it will be given also. But obviously it will be given after some time. But we just want that you come here and you interact. There are some small questions you might have even related to the weekly lecture content that you have, so you can ask your questions over here. Any other questions? You can put it in the chat box. Okay, the exam pattern, I am not really sure about this right now, but any update that I will get according to it, I will provide it to you. And also these questions regarding exam patterns and the lecture contents, please use a discussion forum. There are other course team members also who can give you the answers for this.
Ananya, can I answer on
Yes,
this?
yes, sure, sure, Ishan. Okay, Ishan is one of the course TAs, the teaching assistant, so he can give you an answer for the exam
So
pattern.
the exam pattern will be multiple choice questions, which will be from the lecture class, the lecture the sir is taking, and from the lecture material, which is already given on the uh, separate week respective lectures. So you can find materials on that also, and from the lecture, the sir is just delivering it. So the question will be from both the sets.
Okay, thank you, Ishan. Hopefully that has clarified your query, Mr. Machindra Tamboli. Okay, any other question regarding any of the assignment questions that you have, any clarification in that, or any of the review questions that sir gives after every lecture? You can discuss it right now over here. Okay, in any case, if you have any other questions regarding the presentation that has been shown over here in this session, you can send in questions for that in the link provided right now. Okay, this is only with respect to the lecture, the presentation that I showed. So any questions that you have, you could not answer over here, or you go through the material later on and you have some other questions. So you can kind of type in your questions over here. This can be included in the next presentation that I have, and also if not this, then you can also use the discussion forum where me and all the other course TAs are also going to be there to help you in your doubts, and we'll clarify it. Okay, there's a question: can we use this course for credit transfer for civil engineering branch? Ishan, do you have any input regarding this question?
Uh, this I don't know. You need to talk to your administration, respective college administration, or talk to the administration in NPTEL. Precisely IIT Madras.
Okay, hopefully Venugopal, that answers your question. Okay, so I'm guessing nobody else has any questions right now regarding this. Okay, so hopefully you all will go through the lecture material for week 2 and also the weekly assignment that is given, and we will meet again for the next live session that will be held on the next Tuesday, same timing. And please interact, and any questions, any queries you have, you can ask during the live session, so we can increase the the whole interaction level for the NPTEL course, please. Okay, so thank you everybody for joining, and NPTEL will inform you when these materials will be uploaded on the portal. This course is under civil engineering. It is from the Department of Earth Sciences, because the course material that is engaged and introduced in this course over here actually relates much more to the geology, the subject of geology and the subject of earth sciences. And so the course material that is given over here, it is kind of where our like where we have qualified, where we are qualified, and that is why we are giving it. So it is a course for civil engineering, and we are earth scientists who are taking these sessions, but rest assured that is meant for civil engineering only. It's just we have an understanding about the subject, so that is why. I
I
hope.
think in the I think in the week one lecture, sir has already explained about this course.
Yes, yes,
It's just a course to introduce to the civil engineer student about the background from the earth science information that
yes.
you would be needing in day to day your labs or your field visits and all, so that you can have an in-depth knowledge of that area where you'll be working, where you'll be constructing any building or any other kind of civil structure you'll be going to build.
Yes, and this I also explained when I started the lecture, that this course is to introduce you to earth sciences, and the basics that you're going to learn in this course is going to be used later on in your other civil engineering subjects. So that is the whole perspective of this course. Hopefully, Venugopal, you have got this doubt clear. Any other questions? Okay, so if there are no further questions right now, you can also use the discussion forum and the Google form that I've shared. Please type in your questions, and we'll see you in the next upcoming weekly session. Thank you so much.